Welcome back to Nomenclature Lessons 101 with me, your instructor, Tracy Holbrook. So what I want to do is just remind you, hello, there's a couple of ways we can draw things in organic, and I never want you to forget that. So what you see here is a highlighted area that is the longest, what we would refer to as carbon chain, and that longest carbon chain is 3 all the way across, straight across, left to right. And that has a chlorine on the middle carbon. And then over here, it's the same way. They just drew it a different way. It's the same structure, same compound, same everything, because we still have 3 carbons in the longest continuous chain. It just kinks around on me this time. They've just drawn it in a different way on a sheet of paper. And that chlorine is still attached to that middle carbon, just like it was over here to the left. So, like we've said, the hydrogens can be removed. They can be replaced with other groups if that's what they want to do. And there's different ways to draw these structures. Those different ways are called isomers. But in this case, these two things are not isomers. It's the exact same. So the structure to the left is the exact same as the structure to the right-hand side. They just drew it a different way on a sheet of paper. But it's still ordered the same way. Okay, you're still getting your order at the restaurant. This is what you ordered. There you go. This is in one big plate. Here you go. This was what came from the menu. And then maybe this is still exactly what you ordered from the restaurant, but instead of one big plate, they just served it to you in a different way. But it's still the exact same thing that you ordered. All right, so I told you that we would do a couple of examples, and here they are. So we're going to start with the first one, and it says draw an N-butyl group. All right, so N-butyl. So 1, 2, 3, 4. And this is an N, which means it's going to attach on that primary carbon. So there's the N-butyl group right there, folks. That's all that we need, N-butyl group. And it says structures of pentane, but this is not really pentane. So I just want you to kind of forget about that for now. All right, so there's a N-butyl group. Okay, next, draw an isobutyl group. All right, so the iso unit is a carbon, 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 that little kink. There's your L structure. There we go. So that already represents 3 carbons in a row, right? 3 carbons in total. And then this is butyl, so it wants 4. So I've got to add my 4th carbon onto there. I keep elongating that chain. This kink is what represents the iso unit. All right, next, draw a sec-butyl group. All right, so a sec-butyl group, that means a secondary carbon. All right, so a secondary carbon of 4. 1, 2, 3, 4 in total. Now, I've got to go back, and I'm going to have to rearrange this so that I connect it to a secondary carbon. All right, so if I connect it here, and this is part of the main chain, this R group. Okay, that's not secondary. That's a primary right there, right? Okay, so I'm going to erase that because I know that it can't really be there. So can't connect there. And then if I go through and connect it here, and this is the R group. Well, this carbon is a secondary carbon, isn't it? There's one to the left, and there's one to the right. So this is a secondary carbon, which makes this a sec-butyl group for that reason. So this is the way that we can draw that. And again, that sec is going to let me know the place of attachment. All right. And then finally, draw a tert-butyl group. All right, so a tert-butyl group. That means that where it attaches, it has to be on a tertiary carbon. So this thing has to be tertiary. Just like wherever this attached, that was secondary. This one, wherever it's attached, that has to be tertiary. That's what the prefix means. So that means it has to be attached to 3 other carbons, and there you go. 1, 2, 3. There you go. All right. Next, the note down here below, it says, note, sec only happens with butyl groups. Can we have a sec-pentyl? And the answer is not really, and here's the reason why. If we have 5 carbons in total, that 5 carbons, this could be a secondary carbon, but this also could be a secondary carbon, right? And these are 2 distinct different ways that we can connect this piece to a larger part of the molecule. So after we get really after 4, we don't really see too many secs that are out there, because sec pentyl would mean there's only one choice for a secondary carbon, and we've already discussed that that is not the case. Whenever we have a name, that name should be very clear. It should only represent one structure, and that is it. And here we have a sec pentyl group, but there's 2 different ways for someone to draw this if that was the case. So because of that, this is not a valid name. All right. The purpose of naming is to make sure that that name represents only one structure. That is what this thing is supposed to be about. All right. Okay. So continuing on with this discussion of N and iso and sec, here is just a building up table of what we've talked about so far. Okay. So methyl, ethyl, propyl. And here's the isopropyl group. So isopropyl group forms this L. There we go. Butyl's 4 all the way across. And then here we have isobutyl. So there's the L structure. And then we have a connector piece. The sec butyl, this is just drawn a different way than what we did a while ago, but it's the same thing. This attachment is on a secondary carbon, and that really is the only choice that we have there. A tert butyl, this is a tertiary carbon. It's attached to 3 others. Here is pentyl all the way across. Here is iso. There's my iso unit. Pentyl, because there's 5 in total. Here's hexyl. 1, 2, 3, 4, 5, 6 all the way across. And here's the isohexyl unit. There's the iso unit. That's the L. And if you count the number of carbons, there's going to be a total of 6. Now, let's kind of take a look at some examples. Let's start putting the pieces together. And here we go. Nomenclature. It says write a structure for each of the following. And my first one is isopropyl alcohol. Okay, so I hope this name sounds familiar. It's what you buy in the store to put on a cut or use for other purposes, but isopropyl alcohol. All right, so isopropyl. Prop means how many carbons, people? 3. Right? And the iso unit means it probably makes the L. There's my 3. There's the iso unit. And the iso unit has to connect right there. So there's my isopropyl. Well, what was the alcohol group? Do you remember? That alcohol group was OH. So there's the structure for isopropyl alcohol. I didn't need Google. I didn't need Wikipedia. I just needed to know the rules of some nomenclature, and I just needed to put the pieces together. That's all that I needed. Isopentyl fluoride. Okay, so iso unit is here. There's 3. Pent means 5, though, doesn't it? So I've already taken 3. There's 4. There's 5. So here is my isopentyl group. Well, isopentyl what? Isopentyl fluoride. So I need to put an F here to finish that nomenclature out. So there's the structure for isopropyl alcohol. There's the structure for isopentyl fluoride. The next one, ethyl propyl ether. All right, so let's go back and remember this name for ether. Ether was ROR, right? I said that this was a sandwich, and that sandwich was connected with 2 pieces, one on each side. Oxygen's in the middle. Well, what's it in the middle of? The name is going to tell me what's in the middle of. It tells me the name of the slices of bread, one on the top and one on the bottom. The first one's ethyl. All right, well, ethyl's how many carbons? I hope you tell me 2, because that was a prefix that we kind of needed to know and learn back in the day, a couple of videos ago. So I'm just going to do 1, 2 on this side. You could have done it to the left. I don't care. It means the same thing. It'll be the same thing. Who cares about it? And then propyl. Prop is how many? You got it. It's going to be a total of 3. 1, 2, 3. There you go. What you're going to realize is that IUPAC and those PhD people I told you about that sit around the table to make up all these rules, they really like alphabetizing. So that's why you see E come before P. So if you flipped this structure around and you wrote ethyl to the left and propyl to the right, it means the same exact thing, folks. It means nothing different to me. So if you want it to draw it in the order that it came to you with, no big deal. It's the same thing. You get the right answer. Don't think about these too much. So here is my propyl group. There is my ethyl group, and that is connected with the oxygen, and that's the ether. All right, next is sec-butyl iodide. All right, so butyl, 1, 2, 3, and 4, right? And this 4-carbon chain has to be connected on a secondary carbon. Well, my secondary carbon, I've got one here and one here, but quite honestly, they are the same. So if I put my iodide right there, this would be the same as if I put it to the right-hand side, because this iodide is the second one from the end, and over here, if I drew it to the right-hand side, that would also be second one from the end. So it would actually be the same exact thing. There is no difference there. So there is one way that I could draw this structure. That's the easiest way, I think, to see these. However, some will do 1, 2, 3, and 4. And then right there would be the connector piece, and I would go there. These two are identical. There is no difference because, look, the longest chain of carbons are 4. I just happen to draw them straight across here. And over on this side, the longest carbon chain is still in a group of 4, but they just kinked it around on you here. So this means the same exact thing no matter what you do. I just think that this one is a little bit easier to see, and that's why I draw these, and when I draw them, they're going to be a little bit different from the textbook. And that's okay if you do that too. I just think that you can see them better this way. And then finally, N-octyl bromide. Okay, so octyl is 8, right? 1, 2, 3, 4, 5, 6, 7, and 8. And N means normal. That means it's on a primary carbon. So I'm going to have to draw this bromide either to the left or to the right. It doesn't really matter. I'm just going to draw it to the right-hand side. And there you go. There's my BR. So now you see how all of those individual pieces that we've talked about are working themselves up into the same exact thing here. So write a structure for each of the following compounds, and there you go. These questions are not going to be in Blackboard. These are the types of questions that's going to force you to draw out structures on a sheet of paper, upload them, and give them to me in Blackboard as an assignment upload. So whenever you see these types of questions, that's what you're going to be expected to do. In addition to that, these questions are very easily given on a test, and that's because you're already going to be writing on the test anyway. So you can also expect for these types of questions to show up on that end as well. But in Blackboard, those online, more automated types of questions, there's just no easy drawing platform for you to use in that system. So if they do this in Blackboard, what they'll do is that they'll give you a structure like this one, and they'll force you to go backward into a name. And those will be maybe your multiple choice questions. You know, which one of these is the proper name to this compound? Or short answer. So they'll give you a structure like this one, and they'll say, what is the name of this structure? And you will begin to write that down. So as we do more and more of these practice problems, I think that you'll be a little bit more comfortable with those types of things and those types of questions as well. All right. So in the last video, we talked about primary, secondary, tertiary, right? And primary, secondary, and tertiaries were great when it concerned carbons. However, we also have primary, secondary, tertiary alcohols as well. Okay, so go figure, right? So alcohol, of course, is an OH group. And if that OH group is attached to a carbon, that carbon could be primary, secondary, tertiary. And depending on what that carbon is, that is also what the alcohol is going to be labeled as. So if that carbon is attached to only one other, this is going to be a primary alcohol, all right? If this carbon is attached to 2 others, like here, this is going to be a secondary alcohol. And if this carbon is attached to 3 others, that is your tertiary alcohol. Keep in mind that OH only wants 2 bonds. We learned that when we talked about formal charges. It has one to the oxygen, to the hydrogen. It also has one to the carbon that's attached to. So it's already taken up the 2. So this really is in reference to that particular carbon that the O is going to be attached to in the structure. And that's the difference between a primary, secondary, and tertiary alcohol as well. All right. If you take a look at the halogens, that was also another group that we said that could be formed in this whole field of alkanes that we're getting ready to talk about. That halogen was fluorine, chlorine, bromine, iodine. That also can be attached to a carbon, and if that carbon's only attached to one other, then this is a primary halogen, okay? The same as with alcohol. If that halogen is attached to a carbon that's attached to two others, then this is a secondary halogen, and it's also a secondary carbon, by the way, right? Just like from up above. And then if that halogen is attached to a carbon that's attached to three others, then this is a tertiary halogen, and of course it's also a tertiary carbon. That's why it's a tertiary halogen. So in addition to that, though, we also talked about amines, right? Amines were another group of structures that we could discuss, and that amine group had a NH2 group. But the problem here is that this is a little bit different, all right? This NH2 group can be attached to a carbon. And if that amine is attached to a carbon, only one carbon, then this is a primary amine. Okay? Now, of course, this can continue to go on if it wants to, but the nitrogen is attached directly to only one carbon. This is a primary amine. Now, secondary amines are a little different. Not like halogens, not like the alcohols. If a nitrogen is attached to two carbons, and we had to remove a hydrogen in order to make room for that second carbon, right? So we remove a hydrogen, that takes the place of a carbon. This is a secondary amine. And then if we have a nitrogen that has replaced not one, but two of the hydrogens with the carbons, this is going to be called a tertiary, all right? So primary, secondary, and tertiary amines are regarded a little bit differently than our alcohols and our halogens. It really truly is how many carbons are attached directly to the nitrogen. That is what it's referring to. So a tertiary amine, a secondary amine, and a primary amine. Okay, so let me kind of give you just a summary of what you would see in your text. Here's a slide that you probably will find in the chapter. And over here to the left, this is a primary carbon, so therefore it's a primary halogen. So this is going to be called what they're calling an alkyl halide because it's an alkyl group with a halogen on it. And then here in the middle, this is a secondary carbon, so therefore this is a secondary halide or halogen. And then here is a tertiary carbon. It's attached to three things, so therefore this is a tertiary halogen that we see. Alcohols are the same way. The OH groups are attached to one carbon only that's attached to one other, so that's a primary. The OH is attached to one carbon only that's attached to two others. So because it's attached to two others, that's a secondary alcohol. And then the OH is attached to a carbon that's attached to three things. So that's a tertiary carbon, which makes this a tertiary alcohol. Amines, once again, are different. The amine groups, NH2, that's attached to one carbon, that's primary. Take off a hydrogen, replace it with another carbon, that's a secondary. And take that hydrogen off, replace it with another carbon, and that's a tertiary. So once more, these types of questions, very common in Blackboard, very common on my test. You will see OH groups, or you'll see amine groups, or you'll see the halogen groups, and I will say, what are these? Are these primary? Are these secondary? Are these tertiaries? What are they? And if you look over here to the right-hand side, they give you an example. This nitrogen, right? We see the nitrogen right here. It's attached to one group to the left. There's a carbon up above it that it's directly attached to, and there's a carbon that's directly to the right-hand side of it that it's directly attached to. It's attached to three carbons, one on top, one to the left, one on bottom. Therefore, it's a tertiary amine, and that's how we determine that. All right, so more pieces, more puzzles, more definitions, blah, 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 blah. Now we're going to start focusing on nomenclature. We're going to start slowly putting all these pieces together. So don't freak out on me yet. I know that this was a lot of information that just randomly got thrown at you like a mud fight. But slowly through these examples, you're going to see that this hopefully is not going to be too bad. We're going to do one example after another, after another, after another. And throughout the explanation, I'm going to go back and I'm going to pull out some of these older topics that we have mentioned so far in the lecture series, just to kind of constantly review them and say, hey, you remember? You might not have got this the first time around, but do you remember it now? Does it make sense now? That's what we're going to be seeing in the upcoming videos. So in the next video, we're going to start our first full-blown example of nomenclature, and we're going to put all of those topics and rules that we discussed so far at play. So go snap your fingers, work them out a little bit, crack your knuckles, drink some water, and then come back. And I promise you'll see that it's not as bad as what you think it's going to be.